Now let's just talk about the next question. Question number 4 says that in an equilateral triangle ABC, D is the point on the side BC such that BD is equal to 1/3 of BC. We have to prove 9AD square is equal to 7AB square. So let us suppose if I'll draw this figure, so we can see over here that if this is nothing but an equilateral triangle, and I'm calling this as nothing but A, B, C, and further it says D is a point on BC. So let us suppose there exists any particular D point on BC such that BD is equal to, such that given, let us suppose if I'll write given an equilateral triangle ABC and D is a point on BC such that BD is equal to 1/3 of BC. So what we have to prove? We have to prove over here that 9AD square is equal to 7 of AD square. So let us suppose if I'm doing a construction over here, that I'm drawing a perpendicular AE on BC. Let us suppose if I'm drawing a perpendicular and further I am joining AD as well. So let us suppose if I'm joining AD over here and I'm drawing a perpendicular over here and I'm calling it as nothing but AE. Now let's just start the proof of this theorem. So first of all, for this particular question, we'll start with the proof as let AB is equal to BC is equal to CA as nothing but A. So I'm just taking all the sides as A. So if this side is A, this side is A, and this whole side is A, then further by the question we know that BD is nothing but 1/3 of BC. It means we can write it as BD is nothing but A/3, because BC is nothing but, since BC is nothing but is equal to A, so we can write BD as nothing but A/3. So as you can see, BD over here is nothing but A/3. So let us suppose if I'll write it over here that BD is actually A/3. So this is A/3, and furthermore we know that AE is perpendicular to BC. It implies that BE is definitely nothing but a half of BC. We can definitely see this thing. If AE is perpendicular to BC, then definitely BE is nothing but half of BC. And if this is half of BC, then we can write it as BE is nothing but a half of BC. BC means nothing but A again. So this is nothing but A/2. So hence BE is A/2. So this BE that we are getting is nothing but A/2. So let's just find DE over here. So let us suppose if I'm calling it as 1, I'm calling it as 2. So we can find the value of DE. So as you can see, DE is nothing but BE minus of BD. So this would be nothing but BE is A/2, BD is A/3. So hence after sorting it out, we will get the answer as nothing but A/6. So DE we are getting is nothing but A/6. So this is nothing but A/6. DE is nothing but A/6. Now let us suppose if I'll write it over here, DE is nothing but A/6. So let's just talk about AE side now. So as you can see, in the triangle AEB, we know about this fact that AB square is equal to BE square plus of AE square by the Pythagoras theorem. We know about this fact. By Pythagoras, we know about this fact. So let's just plug in all the values over here. We know AB is nothing but A. So this is A square plus BE. BE is actually nothing but A/2. We know that BE is nothing but A/2. So there is a sign of equality within. So this is nothing but A/2 whole square plus of AE square. Since let us suppose if I'll write it over here from equation number 2, we know about this fact that BE is nothing but A/2. So let's just sort it out. This would be A square minus A square by 4, which is nothing but AE square. And further we are getting AE square as nothing but 3A square by 4, 4, and hence if I sort it out, this would be nothing but AE is equal to root 3A by 2. This is nothing but AE. So we are actually getting AE as nothing but root 3A by 2. So let us suppose if I'll write it over here, AE we are getting is nothing but root 3 by 2 of A. This is root 3 by 2 of A. Now we just wanted to find out a relationship in between AD and AB. So let's just relate it, how we can find it out. So let us suppose if I'm talking about inner triangle AED. We know that in a triangle AED we can apply the Pythagoras theorem as nothing but AD square, which is equal to AE square plus of DE square. We can say this by the Pythagoras theorem. We can say about this particular fact. Let's just plug in all the values over here. We don't know about AD square, but we have the value of AE square, which is nothing but root 3 by 2A whole square, plus of DE. DE is nothing but A by 6 whole square. This is nothing but A by 6 whole square. Now let's just calculate it. AD square is nothing but is equal to 3 by 4A square, and this is nothing but A square by 36. Now let's just calculate it. This would be nothing but 36, and this would be nothing but 9 into this is 27A square plus of A square. This is nothing but 28A square by 36. So actually at the end we are getting a result as nothing but AD square is equal to 28 by 36. So let's just calculate it. So we have 4 into 7 is nothing but 28, 4 into 9 is 36. So we are getting 7 by 9A square. Now we can write A as nothing but AB. Definitely we can write A as nothing but AB whole square. So since let us suppose if I'm saying since A is nothing but AB, all the sides are is equal to A, so we can write A as nothing but AB. Because why we are using this fact? Because we just wanted to have a result that 9AD square is equal to 7AB square. So that's why I'm taking A as nothing but AB. Now let's just take this 9 towards the other side. So this would be nothing but 9AD square, which is equal to 7 of AB square. So this is what we just wanted to prove, that hence let us suppose if I'll write hence proved over here that 9AD square is actually is equal to 7AB square. So this is the thing that we wanted to prove in this particular question. So I hope all the steps related to this particular question is all clear to you, and this is actually, or we can say from this question we can say this is actually the end of our chapter, because the Pythagoras theorem is the last concept that is related to the chapter triangle. I hope all the theorems, all the concepts that are related with this particular chapter triangle is all clear to you. Now let's just practice the more and more theorems and more questions all by yourself.